Fine. Now, the previous discussion we saw that when I create an array or A of 5 elements, it is going to allocate here 10 bytes for storing 5 integer values. If it is a code block, if it is a code block, it is going to allocate 20 bytes. Okay, and A is going to be a constant pointer which will be always pointing to the first location. Fine. When you declare an array, pointer gets created. Same way, what in case if I declare an explicit pointer here, P? Then what is the difference between this A pointer and P pointer? Now what I have done here is I have created an pointer P, and I will store the value of A into this P just by giving here P is equals to A. So A value is nothing but 1000. The 1000 will get stored inside this P. That means even this P is also a pointer pointing to the same location where A is pointing. Then what is the difference between this array pointer and then this P pointer? The only difference is this array pointer is a constant pointer, whereas this P is an variable pointer. A is a constant pointer, whereas this P is an variable pointer. Its value can be changed, but A value cannot be changed. That is the first difference. Second difference is A is an implicit pointer that is automatically created by the compiler, whereas P is an explicit pointer which we have created. Okay, the rest all it is going to be same. So do you mean that in that case, can I give here P of 0 to access the first location 10? P is not an array, it's a pointer. Even if it is a pointer, can I access as an array by giving P of 0? It is possible. So if I give a P of 0, internally it is going to take as nothing but asterisk of P plus 0. So P is 1000, so 1000 plus 0 is going to be 1000. Asterisk of 1000 will give you the value 10. Same way P of 0 also will give a value 10. Same way to access the second location, you can give here P square bracket of 1. So it's going to give nothing but 20. So same way you can also give it as an asterisk of P plus 1. P is 1000, 1000 plus 1 is 1002. Asterisk of 1002 will give you a 1002 location, that is 20. So that means by declaring a pointer and making it to point to the first element of an array, you can access all these array elements with the help of pointer as if this P is a pointer. So you can give here for displaying all these values as an P of I. Same way you can also give it as an asterisk of P plus I. Similarly, instead of giving an asterisk of P plus 0, you can also give it as an asterisk of 0 plus P. Here also you can give it as an asterisk of 1 plus P. That means giving as asterisk of I plus P is equivalent of giving an asterisk of P plus I. When I said when I give here P of I, it takes as an asterisk of P plus I. Similarly, you can also give it as an I of P. So when I give an I of P, internally it takes as an asterisk of P plus I. So that means you can give a 0 of P, you can give it as an 1 of P. Okay, so the code can be written like this. Fine, let's see a program to read 5 array elements and then to display, but displaying will do it with the help of explicit pointer. So in that case, I have declared here array of 5 elements I, and I'll declare one pointer P, and it's of type integer. So enter 5 elements, will read with the help of array itself by giving here ampersand of A of I. And for displaying array elements are here, what I'll do is I'll make this P pointer point to the first location. I'll make this P pointer point to the first location by giving a P equals to A. And for displaying, here we'll give printf %d %d. Here let's give it as an P of I. Same way asterisk of P plus I. And here asterisk of I plus P. And here I of P. Okay. So let's see the output of this. So in the previous case, we had given as an A of I, asterisk of A plus I, asterisk of I plus A, and I of A. But now we are trying to access all those array elements with the help of pointer. Fine. We'll see the output in the code block. Fine, here I have declared an array of 5 elements, a of 5, and I have taken an pointer asterisk of p. So reading is done with the help of, as usual, that is an a of I. Whereas displaying, before displaying, I have made this p pointer point to an same location where a is pointing by giving it p equals to a. If a value is 1000, the 1000 will be stored inside p. And I value is 0 less than or equal to 4 I plus plus. Here I have given p of I of p, asterisk of p plus I, and asterisk of I plus p. Okay, let's see the output of it. Fine, I'll give 5 values. And you can check out here the output. This is going to be a p of I, the first column. Second column is an I of p. So p of I and I of p are going to be same. So the next one is an asterisk of p plus I. Third one is an asterisk of I plus p. That means you access array with the help of pointer, or you access with the help of that same array. Both are going to be same. So you can also give your another 4 more %d, and you access this by giving your a of I, then I of a, asterisk of a plus I, and asterisk of I plus a. Okay, so all 4 places you should get the same values, a of I or p of I of a, and I of p. So all this is going to be same. So let's check out. Compile the code. There's no error. Run it. Enter the values. I'll give the value as 10, 20, 30, 40, and 50. And you can check out all the 8 places it's giving the same value. That means there is no difference between arrays and pointers. Both are same. Arrays internally, they are nothing but pointers.